Okay, so yesterday we saw not this one. Yeah, this one. Yeah, so we talked about what is Spring Boot in terms of web services, how it goes like a request wise. Not much, just a basic overview. We saw how request flows from client to server and how server responds in that way. And they need a medium, so the medium is JSON, and it deals in a key value pair. And then we also saw how we can fix out or have an idea of what is JSON. Okay, so web service is all about a standalone application which is running on some cloud service somewhere on the web server, and then we're trying to use it from other application. So a single web service can handle multiple outgoing or incoming requests, and it's all about how it is configured. The only thing is we are focusing right now that if we have a client and server designed this way, so client when wants to interact and anything, so that goes in a JSON request, and when server wants to return something or wants to return a response, it goes in a JSON. So both ends, client and server, knows what's going on, and accordingly they generate response. Fine. This was from yesterday. Now let's continue the next part. Um, Not this one. I'm just taking the screens again to uh, minimize the timing. Okay, this was the thing, and here we are with some extra stuffs. So in this image, I have explained what kind of uh, what like how our application or API looks like. So treat this as a API. So client is on left side, server is on right side. Okay, great. And then client is right now a code. As of now, when we deal with when we request anything on web server, it is the user who is doing that, at least manually. We have got like I'm the user here. I can open browsers and do the stuffs. Now, if I want to do the same stuff from code, so how it works? So it's a piece of code. So let's suppose we have a client which is written in PHP language, just assume, and a server is on Java language. So language is not a barrier here. That's a good thing. That's why REST became popular nowadays. So PHP says the language, it has a piece of code which says I want a weather information. So how it goes? That's my web request. Dot dot something like HTTP something web domain dot com dot in whatever. Then slash weather and location. So it's saying you can even as a human we can at least understand. So it's asking location of that particular weather. Sorry, weather of particular location. So what is saying that I need ID and the name New York, let's say. So it says I need a location, weather of that location, and that city ID is one and city name is New York. So it goes in curly braces. This is a JSON format. It goes to database or backend or the server, which take the same request. Here it is, and what they did, the Java guy did, they written a code, and they have the same endpoint with them. We call this endpoint. Dot dot slash weather slash location. We call this endpoint. So and within that endpoint, we have a list of location ID. Let's suppose, and then likewise we can have multiple other endpoints like list of location IDs, list of or not list, just a location ID for a specific thing, and region as well. If you have a particular region, so we can have an endpoint for that. So accordingly, it has a code. Right now, we will return that thing, which goes a response, and then it might get something. So when this was the first step. First step says get or give me the weather of this location whose ID is one and name is New York. It goes back to server, server generate response. So that's how your response might look like. So let me just move this piece or this box. Okay, that is fine. I can write here is my response. Okay. So when I request slash weather slash location ID, it gives me a response. So how it get requested? Weather slash one, ID is one, and then I will get a response. ID one, name is New York, temperature something, humidity something, and so on. So this could be a response. So how it looks like? Let me get in the next image. If it is confusing you, let me know if any image confuse you guys. I'll recreate it. Okay. So idea is when we want to request something. Let me get this here. Let's remove this image. Okay, so this is written in PHP language. This is what we are expecting, PHP. These guys are saying, I have a request. It looks like this, and the actual request will look like this. Slash weather slash ID. So this is my request part. Okay, this is my request. Request. Okay, and then server gets that request and accordingly generate response. So when it comes to the response part, which is written in Java language, this is written in Java. And what we have this data in response. Response. So in that response, we can have all this information. The request has weather slash ID and dot dot is something, the domain information. And when we get response, so it will have the JSON. So JSON will have what? How do I know it's JSON? Because it's a curly brace, then it has a key value. How we can say it's key value? Because key is separated by colon and then we have value. So key colon value. And then we have a comma, then comma, and then comma. Likewise, it goes on. So that's how typical REST API looks like, and it's up to us that any language, that code could be written in any language, and that is requesting that particular data. So this PHP is using some front-end code. From there, this gets triggered, and then any language which can consume the data and generates a response. So this is a whole, you can say, picturation of how a API call looks like. So same thing is happening here. Okay, next is the data, like how your XML or JSON looks like. So a screenshot here. Let's take this. Here I have explained how your XML or JSON looks like, how you can modify it for your own purpose. Okay. So question is, which one is better, XML or JSON? So if we talk about this part, left side first of all. So that's your typical XML file looks like. It will have a request body, then username, RAM, password, something, and then request body gets closed. That's your typical XML file looks like within the tags. So request body is the header tag, and it has two sub tags, username and password, and both are closed at the end. That's how XML file looks like. If I have to convert this data in a Java class, okay, just assume you want to do that, and usually this happens. We call this conversion or type conversion from XML to Java file, or XML file to Java file, or a Pojo file or a Pojo class. So how to do that? At least this is a simple file. I can see we just have two information, username and password. So I can create a class and have this kind of structure. So my class name is login and it contains two fields, username and password, and that's it. That's how I can represent my class from this, or you can say I can deduce my class from this data, that it has two fields. So the tags are actually a fields in a class. That's how XML looks like. So, or you can take it this way, if I have to convert this Java class into a data or in an XML format, that's how it looks like. So request body, then subtag, and then subtag. So the subtag will actually a class field. That's how XML looks like. If I have to talk about JSON, this is its JSON data. So you don't have to write a object, just put a curly brace and then go for field, which is username, and the next field password, and then you can give the value. So key is username, value is this, then key is password, then value is 1235, and they are separated by comma. This is a typical JSON object. How do I know its object? Because curly braces are used to denote object. So a simple Pojo class, this login curly brace username password, can be converted into a JSON data by just writing this. Okay. What if it has more information? Instead of just two fields, it might have some nested data like this. Have a look on this class. So we have a class login, Let me show you this way. So we have a class login. It contains three fields: username, password, and a object. It was earlier string. Now we have an address object as an object. So username, password, and one object. And this class address looks like this. And address itself has two properties: state and country. Right? So how we can represent in JSON? This way. So username is the key, password is the key, and then we have the third uh, field. It goes as a key, but because it's an object, so after putting a colon, I'll start a curly brace, and then we can say state and country. You can refer the colors as well. So yellow, that gray or something, and then blue, and then pink color. So you can refer the color, and you can understand that every single field in the class going to be treated as a key in JSON object. And this whole thing is a object. How do I know? Because of curly brace. So this is the big object. I'm just highlighting it. This is the big object, the login class object. And inside this big object, we have a small object that is address. How do I know? Again, curly braces from here. So this is a small object inside the big object. And it has its own fields, state and country. So that's how I can represent a class into a JSON object. This will be really helpful when we write endpoints. This is a prerequisite to understand how API works. Okay, so that's how we convert class into a JSON or JSON to class. We can visualize it so it is understandable. Thing is, we don't have to do this manually. It is done by automatically done by the Spring Boot framework itself. So that's a good thing for us. We can save our energy for some other task. Same way I explained this class, how you can represent it in a more complex way if you have some data. So you should have a better or clear understanding what this JSON looks like. Okay, let's save it first. Okay, so what we have here, we have a class login which contains three fields. Same way, user, password, and address has pin code, city, and city is also object. So how it goes? Two level nested it goes. So big object login contains three fields: username, password, address. Username, password, and address. Address is an object, so body starts and address has three fields: pin code, state, city. So pin code, state, and city is an object. So city will have one more object, city, and it contains name. So name goes here. So that's how you can go too deep in that object. So it is two level nesting, one object here, two level object here, and that's the third one, the big object. Two objects are part of it, and if you can understand this structure of JSON, you can easily understand how my class will look like. There are lots of website out there which says if you want to convert, because sometimes what happens, guys, I'm giving you a real-time example. I was working in a project and they were like JSON data, not just 100 or 200, like thousands or 200,000s or sometimes million lines of codes over there, lines of lines of text in JSON object. So that's how big that JSON data is. So task was to convert that JSON into a Java class through a API call. So it has to be done manually. So lots of libraries are also there which can convert that for you. That will take time. So you have to decide which library should I use, which can efficiently convert that JSON into an Java class, and then you can deal further. Maybe you will get that JSON from third party. Maybe some vendor is out there. They want to deal in JSON. JSON is much easy and much lighter as compared to XML, because in XML you have to write lots of data. Think about again. If you have to write this nested object here, login, then inside login we have some more data, then that data has some more data, like this way. So how hard it would be to represent this data into an XML file? So XML is not an option. So some third party vendor is saying that I have a JSON data and every data is inside there, so you can convert it into a Pojo class, then read the data from JSON files and store it in your database. So you have to write an external code for that. Okay, likewise we have next step, address, which contains this. If it is a list, yeah, this is also case. If you're dealing with a list of objects, so this is the case. Address has pin code, state, and then list of city. So how to represent list, arrays, or collection in JSON? Object, we know it goes in a curly brace. It is clear that curly brace goes in object, or curly brace is used to denote objects. What about collections, arrays, list? This way. in square brackets. And we have seen this in core Java as well. Whenever you try to print your collection, it goes in square brackets. So object is address, or address is a part of, let's say, this user, which contains address, this one. So it contains username, password, fine. So username, password, and then there goes the address. So address is pin code. So first of all, address is an object. So curly brace start, then pin code, then state, and then city. City is a collection. So city has a curly brace, and then city has a list of city. So object, one object, two object. So that's how you denote it. So it's a list and plus it's a object. So collection goes in square brackets, and collection has object of type city. So first city, next city, then object close of city, object close of address, and then object close of class, the login class. So that's how we create JSON for complicated object as well. No questions, so we can move further. Okay, this is a typical flow of REST application. Let me take a screenshot of this. Okay, let's save it. So now I have mentioned that the third party or third party library or project or language is using or calling that API. It could be anything like weather location ID, weather location, or weather region. Whatever the endpoint is, you can request it. And who is doing that? Who is calling it? PHP. But now in a current scenario, if we are here, we just know core Java, little bit of servlets, and some idea of Hibernate. That's what we know right now. We don't know PHP language. So even if by chance we are able to create any REST endpoint, so how to call it? Because we don't know PHP, right? We don't know how to write PHP and then call the endpoints which we have created in Java language. So to do that, we have a tools, some softwares which can be used to request your endpoints. We call them REST client softwares. One of the software is Postman. Okay, so we will also learn that. So this is a REST client, that is Postman. It requests something. Okay, request is like get, put, post, where it goes to a request handler, the actual REST part. So if I have to call or give some name to this request handler, I'll call this login control. Let's say I'm trying to create a login API. Okay, so let me explain you. I think we have one image. Let me check. Okay, it's not here. That's fine. We'll see later. So it's not here, so that's fine. So idea is we have a client. This client say okay, I'm requesting. Again, guys, this is going to be more kind of theory class because you need to understand these terminologies first before writing any API. So client says I want to log in, and when it says login, that means the request goes in a JSON format this way. Let's increase its size 14. Okay, so request goes in a JSON. It says I'm writing in a short UN for username, some ABC, comma, then user password, and then colon, and goes like 1 2 3. So this is a typical request which a client can send. In our case, it's going to be Postman because we are done with the browsers. Now we will use a REST client. No more browser this time. Although you can use it for certain scenarios, we will see what are those scenarios. But for now, we will understand this Postman tool. So make sure that you have installed this software. I'll show you how it looks like. It's Postman. Done. Let's save it. 6th. Oh, we already have the 6th. Okay. 6th. Fine. So this is our REST client, the Postman. It sends request which goes in a JSON object. So how my API will look like? It's up to how we call it. So typically it will be like http colon slash slash some name. Let's say user management. That's my project name. And a slash I'll say API slash users. And it's going to be get request. Okay, that's how my endpoint will look like. Even I'll show you some working examples later. Okay, done. So what client will do? Client will have some code. They will have us architecture, which we will create in our project, the server. Okay. So let's say this is our application, user management. In this project, we will create certain packages. So it is all about login, right? So what I'll do, I'll create, this is a standard practice. We call this MVC design pattern. So I'll call this white caps login controller. Okay, that's one thing. Second level is login service. Next would be login repository. And this is the layer or a package or service which goes and connects with database, the login repository. Okay, that's how service goes, guys. Login controller will call login service will call login repository, and ultimately it goes to database. Then once it has the data, it matches it with the data passed from the request, then it goes back to service, then the controller, and finally we get our response. Let me move a little bit right. Okay, so it generates response. Now in that response, again it's going to be in JSON format, right? So either it could be yes or no. Say status. So it could be success, or it could be move a little bit out, success or fail. That's how I can return the response, and it goes in a JSON object. So this is a typical flow of any endpoint. So what we just said, get request. What we get in response, this. Okay, so same thing is implemented here in this image. So Postman, through Postman we send a client. It's a client. From client we send a request. The request could be get, put, post, which goes to request handler, which is login controller. It goes to a service handler which process request. I know it's kind of blurry, you can zoom in and you can see it. So it process request and prepares JSON response. Okay, and then it goes to database handler which reads database resource. So I'm calling it login DAO. So login DAO or login repository, both are same thing. Don't get confused. Same thing is used for multiple terms. That's how it works. This is, leave it, and yeah, this is fine. Okay, so that's a typical or high level picture of how your API will, the API call flow will work. So it starts from REST client, goes to REST handler, then service, then database handler. And finally, the database handler will connect with database. Right now in our case, we are using Spring JPA as a ORM. No Hibernate. Hibernate will support it, but explicitly we'll say we are using Spring JPA. Spring JPA is also a ORM like Hibernate, but it uses all the functionality of Hibernate. Okay, and this is, I explained the response wise, like how it will look like. What else is next? Okay, now we are understanding the GET request, port request, and other things. Okay, let's take a screenshot of this. So we call this the standard terminology, or the standard word is HTTP verbs. This is really important. It's all about CRUD operations we did earlier. So if we talk about CRUD, so it goes like C, R, U, and D. Okay, so C stands for create, where we actually do insert record. R for read. U for update. Then delete. So this is the scene we have done already. Now when it comes to HTTP verbs, so if I have to create record, it will be post request. Okay, now we will talk about in a HTTP verb language. So HTTP verb says if you want to create, it should be post request. Read, it will be get. Update, it's put request. And delete, obviously it's delete. So now onwards, if we have to perform these operations, CRUD operations, it will take these HTTP verbs: post, get, put, delete. Okay, fine. So this is also clear. Next is what? The HTTP verbs and rest. So get is used to get access to a resource. So we are trying to send something. Here it is says S and I. S for save. That means this is all about how your database gets impacted. Think about you are supposed to fetch something from database, and if you're fetching and you are a legit user, so fetching is not at somehow it is or at some point it's not harming your database. It's not going to change anything on your database. So we call that this request is safe. Let's zoom a little bit so you can see the read the text. As for save, it says do not change the state on the server. State on the server means it is not impacting your database ultimately. So here server is commonly used for a database. There's a term idempotent. What does it do? Will produce the same results irrespective of how many times it is called. So it doesn't matter how many times you have called that endpoint or the REST API, it will always produce the same result. And if anything is happening that way, so we call that this is idempotent HTTP verb. So in our case, if you see safe, so yeah, get request is safe. Doesn't matter how many times you request, it will always return you same record. It is idempotent. If you're looking for ID1, so it will always gives you ID1 if code is correct, and it won't do any modification on your database on your server. Post, it says create a resource. Yeah, we know this. Post is for create or insert the record. So it is cross for everyone. So every time you post a request or you are trying to insert something in database, so there is no idempotency. It will always insert a record, and if it is happening, that means it is first of all not safe in terms of state of the server. Every time, either intentionally or unintentionally, if you request this post endpoint, it will always create a new record in your database, which is not ideal situation. So this request has to be really, whenever you're using it, so you have to very precious, focus that what you are doing here. You should not request this post request blindly. So that's why it is not a safe request. You have to be very cautious when you're hitting this endpoint, and this is definitely not idempotent. Every time you request, it will generate a new result. So no, not safe, not idempotent. So we have to be very cautious when using post request. Okay, put. It updates the records. Yes, we know this. U for update, and we use for updation we use put request or put HTTP verb. It is safe. Again, no, because it is updating the server. That's the purpose of it. So you have to be very again cautious when you're trying to update and when you're trying to use put request. It will update the state of a server or update the database. Intentionally is fine, but unintentionally, if you executed the put request, it will update some record in database. If it is just a one entry, it's fine. Think about that table is linked with 100 other tables. So think about the scenario it will cause. It will be a disaster for the database, guys. That what just happened suddenly. Just one request changes everything in the database just because one IDs are modified. So that's why we have to be very cautious when you're requesting put request. So it is not save request definitely, but it is idempotent. That means think about you are. I just gave example here as well. If ID is one and someone wants to change the name from Ram to Sham, so it doesn't matter how many times you request it. Once it is done, it is done. Either you can call it one time or 100 time. The name is going to be updated only, and if everything goes fine in one hit, it will update the record. Then doesn't matter how many times you call it, the name is already updated, so it won't impact anything. But yeah, it's not save request, it will impact it at least first time. Fine. Same with the delete. Delete is idempotent. You're giving an ID that remove this or delete this entry, and that will get removed from database. And it is again, is it safe? It is not safe, because when you are requesting it, you are actually trying to update a state of a server. You are trying to delete a record. So that's kind of a big thing, deleting a record from database. Usually in real world application, nothing gets deleted. Believe me, no, everyone says, okay, your account is deleted, your account is deactivated. It doesn't matter. If you have posted something on internet, it's always there. You cannot delete anything. We call this, there's a term we call this soft deletion. It's for everyone, guys. We call this, there's a term soft deletion. So maybe it's not visible on your web page, the account you're logged in, but it is always there on the server, on this server, wherever you have created account or nothing or anything you have created there. If you have posted something, it is with them. Maybe they will say it is deleted. No, it's not going to happen. It is always there. We call this soft deletion. That means it's not going to be visible to the user, but it is always there. So be cautious when you're trying to do kind of these kind of operations. So post, put, delete. These are not safe operations, so you have to be very cautious when executing it because they will impact database. Idempotency is one critical term which is mostly used in interviews. That which API is which HTTP verb, or you can say API as well. Which API is idempotent, which is not. So get the APIs which return same result every time you execute them. We call them idempotent. Only post is not idempotent. Then after all the APIs are idempotent. Apart from these four APIs or HTTP verbs, we have four more verbs. Get, post, put, delete are the most commonly used HTTP verbs. Apart from it, we have head, option, trace, and one more is there. So total 8 HTTP verbs are there, which are part of REST API. But again, you guys have to focus on only these four: get, post, put, delete, because on them all CRUD operations are dependent. Okay, fine. Let's move to next image. Okay, now we are moving to. Now we have a basic understanding of how to create how APIs looks like and how many ways are there to create APIs. So this is the first way of, I mean not first. So we have three ways to create Spring Boot application. So usually we go with the Spring initializer. So three ways are CLI, the command line. So if you use command line arguments or commands, you can create the Spring Boot project. And think about this kind of wording. I have to write this you know this black screen and write certain commands, and then it will generate that Spring Boot application. Again, you will lose that UI perspective, so it won't give you any UIs. That doesn't looks good, and nobody even prefer that. Next is STS. It's a IDE developed by the same Eclipse. It will have a same structure. So that's a dedicated IDE for Spring Boot application. So like we have Eclipse, you can download STS as well. And as I mentioned, a dedicated ID for Spring Boot. So this is owned by the Eclipse guys, and they have developed a dedicated software just to work with Spring Boot. That's how Spring Boot is famous. A whole ID is dedicated for the Spring Boot application. So you can also try this STS. STS stands for Spring Tool Suite. You can also search it STS, but again, no need of download it. There it is, Spring Tools. Spring Tools for Visual Code, Spring for Eclipse, Spring for TI. So this website also, I mean, this is a official website, and from here you can download. But again, I don't suggest it. Don't go for STS. It's fine. Our Eclipse is very much enough to do that. The same task. It is capable to do that. If you want to use it and want to use that STS feature, you can also go for help, Eclipse Marketplace, and download that software, the plugin. Again, not worth a while. It will just slow down your Eclipse. So I don't suggest that. So we are left with the third option, which is the Spring Initializer. It's actually a website. Starts with start.spring.io, and then let me give you overview after taking the screenshot. I'll take a screenshot later. Fine. So let's visit this website. I already opened it for you guys. There it is. Let me do with a scratch blank. Okay, so that's how it looks like, start.spring.io. So our website, our official website from Spring Boot guys, they said, okay, if you want to create a Spring Boot application, you can also refer Spring Initializer. So everyone in this world, if they're working with Spring Boot, 99.9% these guys are using Spring Initializer. Okay, why? Because it's really simple to create project from here, and then once you click on generate button, it will give you a zip file, and then you can unzip that zip file and import that project on your Eclipse. Simple enough. Okay, so what it gives you, first of all, it says give the project name, or the type, what build tool you're using. So either it could be Groovy, Kotlin, or Maven. Basically, it's about Gradle. Gradle projects are Maven. These are the mostly used tools in the world in Java. So Gradle or Groovy. So I'll say Maven. We know Maven. Maven is, again, it has a high upper hand on the Gradle. So we'll pick Maven. Then which language? Java, Kotlin, Groovy. So I'll say Java. Then which Spring Boot project? Again, don't go for the latest version. That will impact your project buildup. So I'll pick the lowest one, the least version, the least latest version. So 3.3.8. So this is the actually Spring Boot version we are using, 3.3.8. Fine. Then if you have created Maven project multiple times, and then I can guarantee you guys can see group artifact name. It's the same thing which you have done in your Eclipse. It's similar. If you're not sure, let me do this again. Right click, new, um, Maven project. So it has the same structure what we do in Maven projects. Next, and there we are. Then I have to give the name Maven archetype quickstart. There it is, picked. Next, there it is, group ID, artifact ID, version, package. So it is providing the same interface here on a web page. So group, artifact ID, name, description, everything. So let's give the name. I'll call this com dot, let's say cloud logo. Then demo. This is my project name. So I'll say Spring Boot basics. Okay, we'll get several projects because this is the end goal. We have to learn Spring Boot very thoroughly. So Spring Boot basics. My project name is fine, and I'll say description is optional. I'm just giving it Spring Boot project for basic learning. Okay, no, it's completely option. It will show in our POM file. And let me fix this package name. So my root package, guys, root package has a critical case here. If you don't follow up the package names, and if you don't put every single thing in your root package, you cannot run your application. Yep. So always make sure that everything is right place. So package has a critical place here. So everything's fine. So my root package name is com.cloud.com. Packaging is jar, and I'm using Java 17. You guys can see 17 is there, still there, and latest version so far, which is supported by Spring Boot version. But if you pick 23, you have to use the latest version. And if you use these latest thing, you have to change the other version as well. So to save yourself from that misery, always use the older versions. Even in right now in current project, I am working some latest technologies, and these guys are still using Java 17. So no need to go with latest language, latest version of this language. It is fine if you stay behind it. Okay, so left side is done. Right side, it is all about dependencies. Yeah, same dependencies what we saw in POM file. Yep. So if I open the previous Hibernate project, it has a POM file, and in POM file we saw one tag, dependencies. So what tags we saw? Hibernate core, MySQL, Jakarta, and all this. So these are tags. So same things here. If you want to add dependencies right away, you can add the dependencies. But before going into this section, we have a button, explore. If you click on this explore button, you guys can see it gives you a structure, src, and this is the default structure of how your Maven project looks like. So let me close it, and we are inside POM file, and if you scroll down, you can see we have a dependency here, which is test. And we are sure every time you create a Maven project, you can always see there's a dependency for test cases. So it is always by default. If you want, you can also remove it. So I'll keep it as it is. So that's what it looks like. So right now we just have one dependency. Fine. I'll close this by using this button. And now here comes when you click on this add dependency button, you can see lots of libraries out there. I can use this, scroll down. Lots of libraries. Again, it's not completed. We have lots of things which is not mentioned here, which can be downloaded later. Okay, so right now what I want, because this is going to my web application. REST API is all about web. How do I know? Because somewhere I gave you this example, http :project, and this is actually web URL. So if something is all about web, I need a web library, web jar. So Spring Web, that's the name, and see what it says. Even it gives a one-liner description. Build web including RESTful applications using Spring MVC. uses Apache Tomcat as the default embedded container or server, same, it's the same term. So when you add this jar file, it will give you a embedded server. You don't have to download Tomcat server externally and integrate in your project. No. If you have this jar file, you will get this embedded Tomcat inside it. And definitely it is useful for writing RESTful applications. So I just select it. So just added out one library, web. Let's explore the project again, especially the POM file. And if I scroll, now I can see one more dependency is added. It is about Spring Boot Starter Web. Okay, clear. So that's how your project looks like. Okay, so let me just cover that screenshot. What was it? Not this one, this one. So I need this piece of code here. Goes here. Okay. And I think I should minimize it. Okay, better. Why I minimize? So I can keep dependencies as well. Okay. So this is a dependency we need it. Web. Okay, fine. So once you are comfortable that okay that my project is ready, I can click generate button and then I'll download it somewhere. Then I'll locate it where my directory is. This is the one Spring Boot basic zip. Okay, clear. I'll just right click. Not right click, I just cut it actually. Control X and I'll check where my uh, working place or workplace is. So just looking for it. Okay, so this is the workspace for you guys. I'll just paste that jar file. Here it is. Unzip it. Extract to project. There we go. It has one more project, and then inside this. So what I'll do, I'll just cut this file. Cut. Go back and paste right here. So I don't need to go one folder inside. Paste. Done. Spring Boot basics. Okay. Now it's fine. Now I will do one thing. I'll go back to my clips. Close extra libraries, files, and file, import, and then I will import. This is necessary guys, how to import a existing project in Eclipse. Don't copy paste or never delete any file manually. Always use the tool to do that. So right now the idea is I have generated a Spring Boot application or a Maven project basically. It's a Maven project right now. I just added a one library that is web for Spring Boot to write. I can write REST APIs. But for now it is again a Maven project. So if you have to import a existing Maven project in Eclipse, you have to follow these steps. Right click or you can go for file, then import, type Maven, then existing Maven projects, yes, select, click next, then locate your project. Oh, why it's giving me that way? Okay, this is the project Spring Boot Basics. Select folder, that's the path. Great, then next. So you don't have to generate Maven project from your Eclipse. It's done. It was just for Hibernate because that was a standalone application. Now onwards, we will generate Maven project from this starter app. Okay, so this application and you can see everything is here. SRC main Java, SRC main resources, SRC test Java, the JDK version, Maven dependencies. Okay, let's have a look on that later. SRC is the same what we see here. That's our root package, com.cloudraga. Inside we have a class, Spring Boot Basics application. Okay, I'll open that later. Then target will be empty and then POM file. So let's have a look on POM file. So just two libraries, web which we have asked, test by default it comes up. So I don't need the test file. I can delete it for now. Saved it and it will give an error on test package. There it is. I can delete it. I don't need to add this file for now. Delete it. Okay, so no red lines. Great. Let's open the first file, Spring Boot basic application. And if you see, guys, we are back to main method again. Yes, if you are executing a Spring Boot application, it needs a main method. So main method will never get old. That's why from the first class I was focusing on try to understand how main method works. So yes, even your big projects, big Maven projects or big Spring Boot projects, all will be executed on main method, at least locally. Okay, so we have a main method. Forget about this code. We will discuss it later, maybe on Monday. I'll give you this as a homework to understand this piece of code. I'll give you idea how to understand, how to understand this, because if you're doing it first time, you'd never have a clue what just happened here. What's this all about? So I'll give you a beautiful idea how to understand every single line it has without even knowing it. Whom you can ask. And let's talk about Maven dependencies. If I scroll or expand it, check out what we have in POM file, just one tag, dependency tag, or specifically the Spring Boot starter web. Have a look how many libraries it will use just to run your REST API. Lots of Spring things, some JSON for JSON data. JSON library is all about JSON data, guys. If you have to work in JSON, JSON is one of the greatest library. Then somewhere I can see Tomcat embed core, Tomcat embed element, Tomcat embed socket. So these three jar files will create a environment for you, and you guys can easily work around with this. So you don't have to, again I'm repeating, you don't have to download a Tomcat server from external website and integrate it in your project. No need of it. Spring Boot comes up with the default embedded Tomcat server. The only critical or the only condition is you have to use this library, Spring Boot Starter Web. And if I scroll up, we have a JDK version. If I scroll up some more, so Spring Boot project for the basic learning, that's the description we give. And this is the Spring Boot version 3.3.8, and where it goes inside the parent tag. So parent tag inside POM file determines your Spring Boot details. Okay, so you just need to understand this much data, till description there, this code, and then dependency tag. For now, just focus on these two things. The upper part, which tells you about the Spring Boot application till description, and the dependencies or the libraries you are using. Okay, it is done. So we are good to go. Next, how to run it. So we have a main method, and we know from the first class how to run a main method. Right click, run as application. So we are executing a main method, and let's see how it looks like when you execute a Maven project or Spring Boot application. It gives you a beautiful logo of Spring Boot, the version 3.3.8, and if I scroll right side, I can see a message. It says Tomcat started on port 8080 with context path slash, that's the root, and started Spring Boot application, the class name, Spring Boot basics application in 1.8 second, and some details. So technically, just by executing or running a main method, we have started a Tomcat server. Nice. Can we execute or can we run something on web page? For now, no. If I say local host 8080, that's the port, right? How do I know? It says Tomcat started on port 8080. So I'm on local machine, so localhost. Then the port matters, so it is 8080. Here it is. If I execute this code, it says white label error message. This application has no explicit mapping for error. So you're seeing this as a fallback. So it says not found, status 404. That's why I asked you guys to check out the error uh, types. From it goes from 1000 to 500. So there are some error categories. Have a look on HTTP errors. Okay, but it is giving something that page is not found. Let me stop the server. So how do you stop? Right click on the text where you can see all these contents, right click and terminate, or you can click this red button as well and terminate again and close. So my console is closed, server is down. Let me request this web page again. It is running, you can see, and then it says site can't be reached. That means server is down and it cannot go even determine whether you have a endpoint for this or not. Okay, so that's how you can create Spring Boot application. So that's it for today. What do you guys have to do? I have asked, like, I'm not sure what this class is doing. I'm telling you how to use ChatGPT. If you're not sure or never used any language or code or something, so what you can do, if you have done, so that's great. If you never done, let me do this for you guys. So I'm saying ChatGPT or any AI tool you have access. Just use it, ChatGPT. This is for your own growth. It's not about Spring Boot. So we are done with the Spring Boot. I'm just telling you how to understand any code. So write this code, just copy paste, and right after that you can simply write one line. Explain this code line by line. That's it. This oops. This should be your I statement and enter. Now see what it says. So this is an annotation. This annotation, Spring Boot application at the top of the class. This annotation provided by Spring Boot, it's a convenience annotation that combines three other annotations. That means a single annotation is actually a combination of three annotations: configurations, enable auto configurations, and component scan. I know it doesn't make any sense. Don't worry. It is just for your knowledge that just by adding one annotation, it is a combination of three annotations. That's fine. Then we have a class name, which is doing something. Then we have main method, and even it explains every single term: public, static, void main. Fine, we know this thing. Here's the special part: Spring Boot application, Spring application dot run, and it takes something and then arguments. This line where the Spring Boot application is actually started. Run is method from the application that starts the Spring Boot application, is the class which contains the annotation, and then argument which you pass at runtime, and it closes and this. So in summary, what we understood from here, this annotation makes the class the main entry and sets up the Spring Boot's auto configuration. So one thing is clear that when you are using this annotation, it set up the it set up something for your application, so you don't have to write it manually. Everything is auto configured. As I told you, that Spring Boot is really easy because everything is auto configured there. So you don't have to configure your server. You don't have to write any database connection, at least explicitly. Just mention it and it will create connections for you. You don't have to write those statements, then get connection. Even in Hibernate we did that. We used Hibernate utils class, then we were trying to load the session factory. You don't have to do all that. It is auto configured because somewhere it says enable auto configuration. So this will load lots of things for you. Behind the scene, it do lots of stuffs. Okay. The main method starts the Spring Boot application using run method, which sets up the application context and begins running the application. So I just give you idea in case if ever in future if any line is not clear to you, search this way. Uh, don't use Google. Google is fine, but nowadays if you actually want to, you know, run this application or want to compete with other guys, try to adapt ChatGPT as soon as possible. It will help you, but don't rely on it. It's the case when I'm not available, when I'm not answering, or something is you want to do from your end. You want to search something, so you can just copy and just ask ChatGPT that explain this piece of code. It will give you a very thorough information. You can ask some more question like, okay, what is this? Okay, let's say I don't understand this line. Uh, let's say explain this, not line, it's annotation in detail. Okay, fine. So it will say lots of information. What does it do? What when it just says enable auto configuration. So at least for in a general way, it explains what it meant for. Enable auto configuration. Now it explains lots of other things. It goes in more detail and it will explain what actually it auto configures. So this tool is really helpful when you are learning a new technology. So I suggest go over it. You have a weekend. So on Monday when we meet, I want a discussion on this part. This is the homework, guys. The very first file. So in that case, I want explanation all these things. I didn't matter. It's fine. These things: configuration, enable, and component scan. These are three notation. So I need a working understanding what these do. It's fine if you just read it for me and do your own research what this. See, you can see lots of explanation it gave, and you need a time. So give your time to this question, and then definitely it will have answer. So we are done for today's class. Any question dot? Please tell me, else we can wrap up.
Pankaj, I have a doubt. I'll share my screen.
Okay. Yeah,
So
visible.
here I've imported Spring Boot file,
Mm-hmm.
and so there are two things here.
Mm-hmm.
One is import or junit
Yeah,
jupyter.api.test,
close this file.
and this one is right now what we are talking about.
Correct.
And what is the difference between these two?
This is for
Just
test
wanted to
test cases.
understand.
Test cases. When you write test cases for your project, then we need this file. Spring Boot application tester.
Okay.
So unit test cases basically. So we have multiple types of test cases. This is for unit test case. That's why I have deleted this package. You don't
Oh,
need this right now.
okay. Do you want me to delete this now?
Yeah, you can delete this file. It's a different scope, completely different what we are learning. It's a coding,
Okay.
but a different way.